we end up with tension equal to something absolutely spectacular. Something that is worthy of almost an hour of our time.
For dramatic effect, I think we should wait 5 minutes so it is an hour.
It depends on if Ibrahim wants us to do part D or not.
There's no
Yeah, okay. We can,
Actually, part B is simple, but yeah, part A.
I would like to, you know. So we would just,
So 10.767 divided by 0.543 divided by the sine of 112.93.
something like setting up like that. Like number divided by number divided by number.
Yeah, that would work.
So 18.261.
Units?
Newtons.
So, all of that was to find the tension on the chain
Yes.
that was acting on the ladder.
Yes.
Pretty simple.
I can't wait to have this on the homework quiz.
Oh, okay, I'll make sure it's there.
And
Or not, I don't remember what's on there. All right, so we have 18.26 newtons. What is the force acting on the hinge?
that's the normal force.
Y2.
Y, or, yeah, Y2, so. And
That would be equal to?
Oh, if it's the,
Yeah. Right there.
or my thinking was, the tension's going this way and then it's pushing against that, the hinge at the top that's going that way, so it has to be the same.
Yeah. Wouldn't it be more interesting if they had thrown friction into it?
How would you add friction if it's not moving?
Friction, actually, that would be, what would friction do?
Nothing.
I think that's right, actually, because
It's not moving.
it can be in static equilibrium. Oh, we'd have to have one other piece of information, that's why they threw friction out. With a chain as tight as it is, there's no need for friction. So we would have to figure out, and with friction, we don't necessarily need it chained. So if friction got thrown into it, we would have to tell you how much tension was in the chain, if any.
But again, what would friction be acting on?
Friction would be acting at the bottom. So we'd have an additional force down here.
It was on like that.
my question has accomplished two things. One, the potential problem on the quiz. Two, it has helped us figure out the process behind finding the part D on the I helped the class.
And it also covered one of the things that I wanted to cover anyway. So
Which was?
the dealing with torque that wasn't from forces that were not perpendicular.
So for that, we did some trig with the triangles. We found the angle, and we did like arctan or stuff. We used the angle though, which is the RF sign, whatever that symbol is.
5.
5, yes. And that got us the torque for.
Yeah, the R cross F, the magnitude of R cross F is
Yeah.
just R times F on the side of whatever the angle is. And in terms of the lab, R sine phi is what in the lab I'm calling the lever arm.
The moment on?
Moment arm, yes.
So what is that, or does that not exist in the lab?
What, the lever arm? I call it moment arm in the lab, there's a column.
Yeah, are you saying the R sine phi is the moment arm, or is F the moment arm?
Technically, R is the moment arm,
Mhm.
or the length of the moment arm, but in the lab, R sine phi is what I'm asking you to fill in the moment arm slot for part B.
Another question real quick. Okay, so I'm still back to when we found the tension. Yes. So if we have that equation right there above it and we're trying to find F of T, so are you not isolating F of T by itself?
You are, did you get a different answer?
Yes.
Oh, what you got?
I got like 5.3837, because if you divide out F of T, 'cause like I wrote it down right here because I was gonna ask you. But, cause if you divide out F of T,
Right,
so then you get that,
okay.
and then what I did was, I went ahead and got this answer,
Okay,
and then multiplied that with that, and
Yeah.
I got 5.
because it's already on top, if you
Yeah.
multiplied it, you basically are squaring it on this side and multiplying on that side. You'd have to divide by it and then take the reciprocal.
Okay.
Other questions? For you, Jack.